Hello friends, welcome to my YouTube channel. So, today topic is horizontal pod scaling. What is the concept behind horizontal pod scaling? Okay, so in which situation we are using horizontal pod auto scaling concept in Kubernetes? Okay, so suppose you have one stateless web application that is already running in your Kubernetes cluster. Okay, and during the daytime, okay, during the daytime we are receiving high traffic. Okay, so it means that, and during the night time we are experience very low traffic. Okay, so basically your application is experiencing inconsistent traffic pattern, means high during peak hour and low during rest of the day. Okay, so our goal is our goal is to automatically scale our application so that if number of traffic will get increased pod, the number of pod based on that particular CPU uses also will get increased, and if the traffic will get a decrease, the pod number will also get decrease in that case. Okay, so that is our goal. We need to make such uh, automation script or automation scale pattern so that we can easily control our pod numbers, okay, without any manual intervention. Okay, so it is just like our concept which we have used in our uh, Amazon AWS concept, where we have used auto scaling concept was there, where we already use this type of concept. Okay, where we have set minimum and maximum and desire. Okay, okay, so now same process we are going to implement here, means we can increase or decrease the server based on CPU load by configuring max and minimum set points. Okay, so same process here, we can increase or decrease the pod counts based on our CPU load. Okay, but for this we need to give some configuration to our YAML file. Okay, so here we need to create some YAML file, that ML file tell that currently your pod need to be increased or your pod number need to be decreased based on your load, and that particular YAML file is called HPA. Okay, so let me show you one example. Okay, so here we have some YAML files. Okay, let me get that particular YAML file. This is your service.ml, hpa.ml, and the last one is your deploy.ml. Let me copy and paste it in your our paint. Okay, so the first one is your service.yaml file. So let me explain each and every YAML file here. So the kind, basically the kind here, service. Okay, this define a Kubernetes service resources. Okay, type type is here load balancer, means this YAML file will create an external load balancer. Okay, and that only works on cloud platform like AWS, GCP or Azure. Okay, what is this port 80? Port 80, the port on which the service is exposed. Okay, what is target port? The port on the container that receive the traffic. In this port, the container will receive the traffic. Okay, now come on that selector part. Selector part, we have defined app nginx. So nginx route traffic to ports that have the label app nginx. Okay, that one. Okay, so basically the service exposes the nginx deployment to internet via public IP. Okay, so next one is horizontal pod scaling. Here you can see this. The kind is called horizontal pod scaling. Okay, so basically what it did, it automatically scale pod replicas based on your matrix. If matrix will get increase, pod size will get increase. If matrix will decrease, pod number of pod will get decrease. Okay, so minimum replica is 1, maximum replica is 10. It means that minimum one pod will get created, that is your desired one, and max to max 10 pod only will get created. Okay, it basically sets the range of replicas. Okay, what is this scale target reference? It basically tells us that links the HPA to the deployment name. That name is called Nginx HPA. Okay, okay, this one. Let me change the color. So this one and this one. Okay, like this way. Okay, so it basically links the HPA. This is your HPA file. It links this HPA. This one will links your deployment. Okay, based on your name. That name is your Nginx HPA. Okay. Now come again in that this part, that is your called matrix. Okay, matrix. What is matrix? This one. Okay. So CPU average utilization is 1. Average utilization is 1 means very low CPU threshold, just 1%. Okay, this is basically we are using to test our scaling quickly. Okay, so basically this HPA will scale up the port if CPU users will get exceeded by 1%. Okay. Now the third YAML file is, that is your called deployment.yaml file. Okay. So what is the user of this deployment.yaml file? Okay. It basically manages the nginx pods. Okay. What is replica is equal to 1? So once deployment will get started, one pod will get created here. Okay, you can see this. Okay, by default, one single pod will get start. Okay, match label. This match label. What is this nginx? The selector used by the service and HPA. Okay, this is your match selector. Okay, what is this your resource? So request CPU 250M millicore means request 250 millicores of CPU, and that CPU will taken from your nodes. Okay, this CPU is taken from your nodes. Okay, this is request for HPA to make scaling decision. Okay, these deployments start one pod of Nginx, and the HPA can scale it based on this CPU loads. Okay, so let me tell you the overall flow. So in deploy.yaml file, okay, we are deploy one single Nginx port, okay, with our CPU request. Okay, in our service.yaml file, we are exposing it to our internet using external load balancer. Okay, this one. And the last one, that is your call HPA.yaml. It enable the auto scaling from 1 to 10 post based on our CPU loads. Okay, it set the trigger, that is basically 1%. If 1% will get, we will already set our average utilization, that is called your 1%. Okay, so let's try to execute this first. Okay, so but before, the prerequisite is to start our HPA, matrix server should be installed here. Okay, so let me see. Okay, let me see first if matrix service is installed or not. Okay, so how you are going to check if matrix server is installed uh, in your cluster or not? Let me verify that things. Okay. So let me try to see if that matrix services is running or not. Okay. So it is under cube system namespace. Okay. So how many namespaces are running? You can also check kubectl get ns. Okay. So in that particular cube system namespace, okay, if you can see this matrix service is server is running. Okay, you can also install it, but let's try to without install. You can also check the logs also. Okay, now next step is to apply our deployment. So kubectl apply -f service.ml. Let me execute it one by one. HPA.yaml. The last one is your deploy. Okay, so now see if services is created, pods is created or not. Minimum one pod should be create here. Qctl get pods. Perfect. One is running services, or you can write SVC also. Okay, now it is running. Check the deployment part. HPA. Perfect. It is running. Okay, so now, so we need to run this load balancer URL here. Okay, try to execute it. It should not run here because we haven't enabled the security group. Let me go in our security group. Okay, so instance security, go to inbound rule here. Now edit inbound rule, add all traffic. Okay, done. Now try to re-execute it. Now you can see this, it is running well. Now our next target is to increase the load. Okay, so how to increase the load? So this is one URL to increase the load. Let me try to execute it. Okay, and let's see if it is running. Okay, okay, it is running perfectly. Now see if load is getting increases or not. You can see this matrix is getting changed here. 0%. Okay. Watch and try to see. Yeah, you can see this. It is now 3%. Let me check the pod also. kubectl get pods. Perfect. It is. So I have created one more tab so that you can execute it here so that load will also get increase again. If you want to put sleep 50 seconds, okay, copy this, control C, put it again, okay, or now, definitely load will get increase here, okay, and pod size will also get increased 1 2 3 4 5 6 7 8 9 10. Now you can see this 10 pod is getting created here, okay. So this is the concept behind HPA. If load will get increase, pod will also get increase. If load will get decrease, so pod number will also get decrease here. Okay, so that is all over about your HPA concepts. Okay, so we will create next video based on some new concept of Kubernetes. Till then, bye bye. Thank you very much.